this video is on finance, on annuities in arrears, changing circumstances. We'll be using questions from John Short's Compendium of General Maths. We're learning to solve annuities in arrears problems where something changes. Kinds of things that might change are the interest rate, the amount you repay, introducing a cash injection partway through, and we'll also look at how you might find hidden fees. So, we're going to be using the annuities and arrears formula here with our usual P, R, I, and N, just remembering that N is the number of periods remaining, not the number of periods that have passed. If we're saving money on a bank loan, things that we can try and do are to shorten the time frame if possible, to make lump sum repayments more effective if we do them. Make fortnightly repayments rather than monthly repayments if you can, because you can fit in an extra payment, and refinance the loan at a lower interest rate if possible. Okay, so here's the example we're looking at. David borrows $120,000 over 25 years, 8.2% paid in monthly instalments. Find the size of each repayment. So we know P, we start with 120,000. We know I, 0.082 divided by 12 because it's monthly, and we know N is 25 years and it's monthly, so 12 times 25. Okay, so if we substitute into the formula, we get 120,000 is equal to R times 1 minus 1 plus 0.082 over 12 to the power of negative 300, so there are 300 periods remaining at the beginning, and divide by our interest rate there, 0.082 divided by 12. So if you do that on your calculator, just working out this right hand bit here, I get 127.37, so it's 120,000 equals R times 127.37, and then do 120,000 divided by 127.370395, and there's my repayment, $942.13. So there we have our value for R. Now, find the total repaid over 25 years and the amount of interest paid if it runs its full course. Okay, well the total repaid over 25 years, that's going to be 25 years, and we're paying monthly, so we have 300 payments at 942.13, which is equal $282,639. Now the amount of interest paid then is $282,639 minus the 120,000 that we borrowed. It's the difference between what we pay and what we borrowed. So that's going to be 162,639. That's just the interest. So you pay $162,000 in interest. Now, next question. After 4 years, how much is required to pay off the loan? So what we have to do is just try and pause it at 4 years and work out how much we owe. So P this time, we don't know. We're going to try and work that out. Our repayment, as we know, is 942.13. Interest rate hasn't changed. That's 0.082 over 12. And N, now after 4 years, that means we have 21 years remaining. So it's 21 times 12. That's the number of periods remaining. So if we sub that in, we get P equals our repayment, 942.13 times 1 minus 1 plus 0.082 over 12 to the power of negative 252. That 252 comes from this value here. That's how many we have left. And divide the whole thing by I, which is 0.082 over 12. If we do that, put it in your calculator, you'll get a value of P equals $113,088.95. Okay, so next part of the question, how much principal has been repaid at this time? So the amount of principal that has been repaid is the difference between what we borrowed and what we owed. So we borrowed 120,000. We still owe 113,000, or rather, David does. David owes 113,000. So he owes a total of $6,911.05. Now, why is the amount so small? Because in the early days of a loan, you are only, or mainly rather, paying off interest. Now, calculate the total repayments made over the first 4 years. He makes 4 years worth of payments, 12 monthly payments a year at $942.13, and that comes out at $45,222.24. After 4 years, David inherited. Now, sorry, just to compare those two numbers, that means that he spent $45,000 to pay off $7,000. The rest of it, the $38,000 or so, was interest. Now, after 4 years, David inherits $30,000 and decides to put this money towards reducing his loan. How much principal has to be repaid? Well, he did owe at 4 years $113,088.95. Take away the $30,000 there that he's putting in, and he's left owing $83,088.95. Okay, he decides to repay this over 12 years. What monthly repayment is required? So the most important thing is now that we recognise we have a new PV because we've stopped our loan. We're going to recalculate it, and it was $83,088.95. So, the interest rate hasn't changed. That was 8.2%. He's going to pay it over 12 years, which means it's 12 times 20. Oh, sorry, 12 times 12. 12 years monthly payments. We're going to work out that. We don't know it yet. FV, we're paying the loan down to 0, and it's still 12, 12, and we should also note its end because we're doing annuities in arrears. Now, if you do that on your calculator and hit payments, you'll get a value of $908.54. Calculate the total amount David repaid over the 16 years. So what we're saying here is he's done 4 years at the old repayment. That's 4 lots of 12 monthly payments at $942.13, and he's just made 12 years. So 12 years, 12 monthly payments, $908.54. And he also paid $30,000 as a one-off. So the total is $206,052. Sorry, $206,052. That's the total amount that he repaid. Now, if we compare that to what he originally was going to pay back, he was originally going to pay back $282,639. That's if he just paid back 25 years, 12 repayments a year at $942. So it's $282,639 minus. So we're looking for the difference. How much has he saved? Minus the $206,052 he paid that way. He saved $76,000. So by making that cash injection of $30,000 and by repaying it faster over 12 years, he saved $76,587. Okay, now changing a mortgage to a better interest rate and changing the repayment amount. So Mark originally borrows $285,000 from Eastpak at a rate of 5.3, compounding fortnightly over 30 years. Now we've done an algebraic version of finding the repayment, so we'll go straight to our finance mode. So we have $285,000 is how much was borrowed, 5.3 is the interest rate. We're going to finish on 0. We're calculating that. It's fortnightly, so 26, and this is our 30 years monthly. Sorry, fortnightly, so 26. Click on payment and we get $730.09. That's the fortnightly repayment. How much will he pay back over the course of the loan in total? Well, $730.09 fortnightly every year for 30 years. Gives us a total of $569,400. That's on a loan of $285. Now that's about normal. We're usually expecting to see over the course of a 25 or 30 year mortgage and an interest rate somewhere between 5 and 10%. It's going to be round about double. I mean, not exactly, but it's not unusual for you to be borrowing $2 or $2.50 on the dollar in terms of what you pay back. Now, after 8 years, Mark sees that any bank is offering a much cheaper interest rate, compounding fortnightly. So he maintains the same payments. How much does Mark save over the course of the loan by switching? So, after 8 years, the first thing we have to do is work out, or pause the loan and say, well, how much does he owe after 8 years. That's the first step. Okay, so after 8 years, there are 22 years remaining. So 22 times 26 periods remaining. 5.3 stays the same. We're working out our new PV. We keep our payment the same, and 26, 26, and 251,313 and 13 cents is how much Mark owes at that stage. So that's again not unusual that he's not paid off very much, but we're going to get 251,313.13. Alright, that's the answer to our first bit. After 8 years, that's what he owes. So we've got a new PV of 251,313. We're now going to resolve on the CAS using the cheaper interest rate, and we'll see how much we save. Now the difference here is going to be, it's going to save us time. So we're at 2.8%. We're finishing on 0. We keep the payments the same, and we now pay it off in 430.3 payments. Okay, so what we want to do now is work out how much did we pay, or would we have paid using the old method, which was 569,400. How much would we pay using the new method, and then work out the difference. So the difference here is that we did 8 years at the old method, so 8 times 26 times 730.09, and we're going to add then our 430.3 lots of 730. Oops. Of 730.09. So that's 8 years plus our now shortened amount, 430 periods, at that amount as well. So we're going to work out what that is. And we get, so it's 430 times 730.09, that's 313, plus 8 times 26 times 7309, oh sorry, 730.09. Okay, so he's paying back a total of 465,797. 465797.42, and the difference there, here you can see the difference is $100,000. So the original 5.3% payment, 569,400. Then we recalculated by saying, okay, he paid that rate for 8 years, then he paid a new rate which shortened the amount of time, and he get the same repayment amount, and that totaled 465,797. So a difference of $103,602.58. Okay, here we have a question involving account keeping fees. Matt borrows $15,000, 7.2% interest, compounding monthly. Okay, so over the course of the loan, he pays back $469, 3 years, 12 months, total of $16,884. Which is $1,884 more than he borrowed. Now the fine print says he's being charged a monthly accounting fee of $4 to $5. So the first thing we should do is work out what should his monthly repayments be. Okay, if we use this screen here, 12 monthly payments, 3 years, 7.2%, $15,000. His repayment should be $464.53. So if that's what he should be paying back, but he is paying $469, then we can see that the difference is what he's being charged in fees. So we get 469 minus 464.53 gives us a fee of $4.47. So that is the fee, $4.47. Okay, so that's it. Just remember, with changing circumstances, you can change the rate, change the repayment, you can inject funds. Always remember to stop the loan, so just pause it, calculate how much is outstanding, and then use that amount to start again, and everything follows from there. Thanks very much.